All right. The other type of factoring we're going to do is this harder method when harder problems when a is not 1. So here we'll have an example uh, where the value in front is not necessarily seen. However, uh, we'll find out shortly that the a value turns out to be 6. And so let's just box method this real quick. So 6x plus 1, x minus 10. 6x squared is here, x negative 60x, and negative 10. So this statement here is the same as 6x squared minus 59x, so add those, minus 10. And so if we analyze this, the trick that we used for easier problems no longer quite works the same way. So the negative 10, if we look at these values here, that's still the same as before. You're still thinking about which two numbers, if you reverse this, multiply to negative 10. However, the adds to, negative 1 and negative 10, they don't add to negative 59 because the 6 is kind of messing with the process from before. So in this case, it's easier to look at these coefficients and think about, well, what multiplies to 6? And there's a couple options. In this case, we saw it was 6 and 1. So this is 1x. And so that's sort of the thinking that we're going to use on this one. So let's practice factoring. The second one, the things that multiply to, actually, I should start here. Let's start with this 2x squared. The only way we're going to get a 2x squared is if we have, let's do this black, 2x and x. So those two, when they multiply together, we have 2x squared. Now, the 3 is, there's not too many options for that. So this was 1x and 2x. And so we have those here. The 3 is 1 and 3. And then the question is just where do I put them? Is a 3 here? Is a 3 there? Because it makes a difference with the 2 being in the problem. Overall, when we multiply them, the 2 will add up to 7x. So if we put a 3 here, this 3 times this x, 3x. In fact, the 3 has to be on this one because this 2x times this 3, that makes 6x. And then the plus 1 here. So we're kind of just puzzling through this. And what I'm thinking about when I'm considering my options here is I'm thinking about if you have 2x and x, and this is what I'm visualizing here as I problem solve this, that is 2x squared. Okay, that's it. And then I knew that the other numbers here were 1 and 3, but I wasn't sure which one went where. And so I'm thinking, well, the only way to arrive at 7x is if we have 6x, and put that because the 2 there, and x, meaning that the plus 3 and plus 1 have to be in this order. And so I'm sort of reversing the box method in my head as we problem solve this. So let's try these other ones too here. All right. The 5x, there's only one way to do that. It would be 5 and 1. And so I'll just put the 5x and the 1x, or actually just leave it as x. Looks better. Okay, and then things that multiply to negative 4 are 2 and 2 and 1 and 4. And one of them is going to be negative. So this is where we have to sort of consider all our options, and that's the downside of this method, is that it is a lot of sort of critical thinking, which is can be exhausting if you're doing a lot of these. So if I put a 2 and a 2, and one of them is going to be negative, so it's either could be negative 2 and positive 2, and then this one it could be negative 1 and positive 4, or it could be positive 1 and -4. So there's a lot of things to consider. And if you put let's see, we have to have negative 19 x's. So the 4 I'm seeing is here because that would multiply against the 5x and the 1. And then overall we have negative 19 x's, meaning that the 4 is negative and the 1 is positive. Now, again, I'll show you what I'm thinking when I'm doing this here. We already have 5x and x. And we have a -4. And so what are the two other numbers here, which are what's in the parentheses? So 2 and 2 are out of the question because they won't get me to the 19. And 4 and 1 are left over here. Now, if I put a 4 here, this is going to be 20x. But I need negative 19x's, so that's why I knew this one was negative. And then this one would be positive. So that overall these add up to negative 19. So you can use the box method to try to puzzle this out. But really that's what I'm visualizing as I make my decisions as to what numbers are going where. Last one. Okay, this one, 1 and 5, that's easier. But now the 6 is kind of throws a wrench. It could be 1 and 6 like the problem above, or it could be 2 and 3. And so there's a couple options to consider here. This could be 2x and 3x. Or it could be 6x and 1x. And then the 5 and the 1. So there's a lot of combinations here to think through. At this point, this is about the limitation of a problem like this with this method. After anything more challenging, you would need a bit more of a process to follow. So thinking about what could be here or here, it's a 1 and a 5. And it's just a question of which one and is it 5 and 1 or 1 and 5, because that does make a difference. Overall, it has to add to 13 when we multiply it out. And so the only way I'm seeing that the 6 and the x, let's see, now that would be too many. There's no way to get 13 out of that with a 1 and a 5. So that's why I think it's this one, 2x and the 3x. And then if you put a 5 here, that 2x is going to multiply the 5 and make 10x. Put the 1 here. So this is not possible. Okay, so here's what I'm thinking. We had 6x squared, and I thought it was probably 2x and 3x. And we have 5. And so it's 1 times 5, and then just had to figure out where they went. And since it's add up to 13, this would be 10x. So it'd have to be a 5 and a 1 to multiply to make this puzzle come out. Okay, again, like I said, that's about as tricky as they get with this method. And so that's the answer, 3x plus 5, 2x plus 1. So this is the figure it out method. It's not necessarily the preferred method amongst students, but it's a harder and ultimately a better long run strategy.